Hi students, welcome back to this wonderful chapter, Chemical Kinetics. In this module, we are going to cover a multiple choice question on isolation method. Let's take a look at the question. The following kinetic data is provided for a reaction between A and B. This is the data that's given to us. Initial concentration of A, initial concentration of B, and the initial rate of formation of D has been given to us. The value of rate constant for the above reaction is equal to, which means we have to find the value of K. And our options are 1.15 into 10 raised to minus 4 dm cube per mole minute. B, 2.3 into 10 raised to minus 4 decimeter raised to 6 per mole square minute. C, 2.3 into 10 raised to minus 2 decimeter raised to 6 per mole square minute. And option D, 1.15 into 10 raised to minus 2 decimeter cube per mole minute. These are the four options that we have. Now here, for this numerical, or rather for this multiple choice question, I can say that the rate law expression is rate is equal to K into A concentration raised to alpha into B concentration raised to beta. Now here it's pretty obvious. If you observe the table well enough, you will see that when A is constant and B is doubled, now if you pay attention, this happens in the first two rows of the data where A concentration is constant and B is being doubled. When this happens, when A is constant and B is being doubled, in that case, you can see that the rate increases by 2 times. From 1.15 into 10 raised to minus 4, it is now becoming 2.3 into 10 raised to minus 4. So in this case, I can say that the value of beta is 1. If B is being doubled, the rate is also doubling. So beta has to be 1. In a similar fashion, if you see, when the concentration of B is constant and A is doubled, now this happens in the last 2 rows. If you see, the concentration of B is constant and A is now being doubled. So in that condition, it's pretty obvious that the rate increases by 4 times. B is constant. Now when A is being doubled, the rate increases by 4 times, which means obviously the value of alpha happens to be 2. So when I take these values of alpha and beta and I substitute them in the rate law, I will get rate is equal to K into concentration of A raised to 2 into concentration of B. Now here, all I have to do is, see, I have found the order. Order is known to us. Now we have to find the rate constant. In order to find the rate constant, all we have to do is take any one of these rows, substitute it here in this equation. So let's do that. We get 2.3 into 10 raised to minus 6 is equal to K into 0.01 square into 1. We have substituted the third row over here. So when we solve this expression, we get the value of K as 2.3 into 10 raised to minus 2. So once again, if you take a look at your options, the value of K has to be 2.3 into 10 raised to minus 2. So option C happens to be the correct answer. So that's how you have to solve these MCQs. First, you have to find order of the reaction with isolation method. From there, you substitute any one data in the rate law equation, and there you go. You have your answer of rate constant. That's all for this module. See you in the next module. Thank you very much.